Okay, practice set 5, and we've completed quite a bit here. So we've done all of these as I'm going through them. In this last one, we looked at balancing and reaction types, and that brings us to our first reactions and looking at calculations within the reaction. So propane gas reacts with oxygen to produce water and carbon dioxide, and propane has a density of 2.02 grams per liter at room temperature. Excuse me. So write the balanced equation. So we're going to start with propane, which they tell us is C3H8. They tell us that's going to react with oxygen. So plus, remember oxygen is diatomic, so that's going to be O2. And we're going to produce water, H2O, and carbon dioxide, CO2. So of course that's complete combustion. All right. So to balance this, I have 3 carbons in my propane, so I'm going to throw 3 carbons in, 3 in front of the CO2 to get my 3 carbons. And then of course we have hydrogen, there's 8 of those, so we're going to put a 4 in front of the water. That's going to give me my 8 hydrogens. Now to figure out the oxygens, we'll do 4 times 1. That gives us 4 oxygens here. 3 times 2 gives us 6 there. That's going to be 10 oxygens. Luckily that's an even number, so we'll just cut that in half. And we'll put a 5 in front of the O2. All right, part B, how many grams of water form with 5 liters of propane reacts? So I think that's supposed to be when 5 liters of propane reacts, but that's okay. So when, not with. All right, so when 5 liters reacts. So if we have 5 liters of propane, we need to get that into a mass. And so up here we're told we have 2.02 grams for 1 liter. So realistically then what they're asking us is, we're going to take 2.02 times 5, is we have 10.1 grams of propane. I'm just going to put that as pro down here. And they want to know how much water will we make. All right. Now it's not mentioning anything about limiting reagents, so we won't have to worry about that aspect. So if you're already ahead in the videos and then you've come back to start working on homeworks, that's not really what they're asking here. Really what they want is just that 3-step mass-to-mass conversion that you've been working on. So we're going to set up the 3 steps. The first thing we want to do is get moles of propane. So for every 1 mole of propane, we're going to go to our handy-dandy periodic table. And we're going to have 3 times 12.01 plus 8.08 for the hydrogen gives us 44.11 grams for every mole. And then according to our reaction, for every 1 mole of propane, we're going to form 4 moles of water. So at this point, moles of propane would cancel out, grams of propane would cancel out. We'd be in moles of water, but they're asking us specifically for grams of water. And so for every 1 mole of water, we're going to get 18.02 grams. Now moles of water would cancel out, and now we can just run this through our calculator. So we have 10.1 divided by 44.11 times 4 times 18.02. We get 3 sig figs here, and so our final answer will be 16.5 grams of water. All right. Now, how many grams of water can be produced from the reaction of 8.50 times 10 to the 22 molecules of propane? So very similar to what we just did, we have to get from molecules to moles. So molecules of propane to moles of propane. Then we'll use our stoichiometric 4 to 1. And then from there, instead of going to grams of water, we'll actually have moles of water. And so, oh no, they want grams of water again. So we would go grams of water again. So I don't have a whole lot of space down here to work with. So what I'm going to do is I'm going to go and erase all of this. And I'm just going to go ahead and put it in here. So we have 8.50 times 10 to the 22 molecules of propane. Just like we saw way back on those first problems, we're going to convert to moles still, right? I want to get to 1 mole of propane, except instead of using the stoichiometry, or excuse me, instead of using the molar mass, we're going to use Avogadro's number. So 6.02 times 10 to the 23 molecules. Molecules will cancel out. At this point, we would be moles of propane. And so these next two steps would look very much like the last problem. We're going to go from 1 mole of propane to 4 moles of water. And then, of course, from 1 mole of water to 18.02 grams of water. And so now, I'm going to take 8.50, divide that by 6.02. I'm going to multiply that by 4, and then multiply that by 18.02. And then with 3 sig figs, we get 102. However, we have 10 to the 22 minus 23, so this would be times 10 to the negative 1, and that would be grams of water. And so up here, I'll finish this off. We're going to move this, well, we could either move the decimal over 2 places, or we could just get rid of that minus 1. So it could be 1.02 times 10. And of course, if we move this over 2 times, we made a big number small, this is going to go up twice. So 10 to the 1. Or we could simply have 10.2 grams. Either one of those would be acceptable. All right. So those are those 3 problems. We have 1 slide left, and so that'll be coming up next.